Welcome to the Chapter 5.1 lesson videos. Today we're going to be starting our first part of Chapter 5, Fundamental Identities. Now, this is a big change of pace from things that we were doing, and this is often considered one of the hardest chapters of the year, so I strongly encourage you to take some really great notes. Make sure you're paying really close attention to these videos and actually give them time. If you don't get enough time to watch it right this moment, make sure you take the time to go back and re-watch different topics. If you slack off, this will be something that'll be very, very easy for you to quickly fall behind. So please make sure you give it your full and complete attention as much as possible. All right, so a couple things we're going to do today. We're going to talk about these fundamental identities that you have to memorize. Now, yes, you absolutely have to memorize them. You have to be able to reproduce them when you're live in person in class. You can use the fundamental identities to manipulate and simplify expressions. We'll do some examples of that. And we can find trig function values given a quadrant and one of the values, and we're going to use the fundamental identities. There's a way we've done that before, but there's a little bit of a new way that we're going to talk about how to do it. And then you can express one function in terms of another using trig identities, so how to kind of manipulate and change between them. All right, so we're first going to introduce the fundamental identities. I'm then going to give you a kind of a screen that I would say is something you definitely want to copy down or put on an index card, something that you can have for reference until you memorize them. But these first ones are ones you should absolutely memorize. So I'll just talk about them very briefly, and then we'll do some practice problems with them. All right, so what is an identity? Okay, so the word, when I say the word identity, it's kind of a mathematical given. Now, we're going to prove more of these as we go, and so that's kind of the idea of this chapter. It's kind of like proofs in a way, if you remember geometry proofs. But an identity is something that we know is given to be true, like x squared equals x times x. Right, so that's something we know is given to be true, or 3x equals x plus x plus x. So these two things are what we would call identities. They're things that we know to be true because we know how mathematics works. We know the kind of underlying causes and reasons why these things are the way they are, and so it's what we call an identity. It's an equation that is equal, so the two halves are going to be equal. Basically, you can substitute one in for the other. So substitution property is really important for what we're doing. So if you have an x squared, you can change it to an x times x at any time because you know that it's an identity. Okay, so here's our first identity. So this one is called the negative angle identity. And this is one of the less used ones, but it's something we should talk about just to be clear real quick. So the sine function and another version of the sine function, the way it works is that for the negative angle identity is if you have the sine of some negative angle, it's the same as negative sine of the positive angle. So like the sine of negative 20 is the same as negative sine of positive 20. So if you ever have the sine of some negative number on the inside, you can actually take that negative and pull it to the outside, and that's how it works for sine. Now cosine's a little bit different. The cosine of a negative angle is always the same as the cosine of its same positive angle. So using our same example, the cosine of negative 20 is equal to the cosine of positive 20. So here they were opposites, one's positive and one's negative. So like one would be like 0.3 and one would be negative 0.3. That's because sine's an odd function. Here, since cosine's even, they are the same. Tangent is the same as sine. It kind of matches the same as sine. The tangent of a negative angle is equal to the negative tangent of the positive version. So tangent of negative 20, you can take that negative out and do the tangent of positive 20 instead. So sine and tangent, the negative does a change. So the negative angle does affect it. It makes it opposite. But cosine, it doesn't. Whether it's negative 20 or positive 20, you get the same answer either way. So that's called our negative angle identity. All right, reciprocal identities. This is another one that we're pretty familiar with. I only have 3 of them written here because it kind of goes to be said, unspoken, that the other way is true as well. I'll write it down here in just a second, though. But the secant of an angle is the same as 1 over the cosine of an angle. And this is going to be a really useful thing. We're going to do a lot this chapter, is changing these less familiar trig functions into their reciprocal versions of the more familiar trig functions. So if you see a secant, changing it to 1 over cosine, or if you see a cotangent, changing it to 1 over tangent. If you see a cosecant, changing it to 1 over sine. Likewise, it goes the other direction as well. If you have a 1 over secant of theta, you can change that into a cosine of theta up in the numerator, so cosine of theta over 1. Or if you have a 1 over cotangent of theta, you can change that into a just normal tangent of theta, or vice versa. Or if you have a 1 over cosecant of theta, you can change that into a sine of theta. So the reciprocal allows you to flip your secants, cosecants, and cotangents to become cosines, tangents, and sines, or vice versa. You can go either way you want if it helps you for a certain problem. Okay. The next one is called the quotient identity, and this is new for most people. I would assume. I don't know if many of us know this, but so something we kind of hopefully remember a little bit is that sine of an angle is our y value, cosine of an angle is our x value, and tangent of an angle is our y over x value. When we're talking about our triangles and the quadrants, and this is our x and our y and our r. So when we're looking about those in a kind of the unit circle, sine was the y, cosine was the x, and tangent was y over x. Well, since sine is y and cosine is x and tangent is y over x, we can change this y over x to be sine and cosine. So tangent of an angle is equal to the sine of the same angle over the cosine of the same angle. So if you have tangent of 20, you can change that to be the sine of 20 over the cosine of 20. These are interchangeable. Likewise, since tangent and cotangents are reciprocal, cotangent of an angle is cosine over sine. So being able to flip from having a tangent to having some sines and cosines instead might be something that comes in handy this chapter and something you end up doing. All right. All right, and the next ones, these ones are a little new as well, I believe. There are 3 variations of the same thing, and so I want to point out the main one. The key, so you really have to memorize all of these. That's kind of the easiest way to do it. But the key one right here is this top one. Sine squared plus cosine squared equals 1. So the sine squared of an angle plus the cosine squared of an angle is equal to 1. And you can do this for any angle, and it'll always be true that the sine squared of the angle plus the cosine squared of the angle equals 1. All these other ones are just variants on the first one, but they use the other trig function. So it's kind of nice to memorize it. So this one, for example, is if we divided everything by cosine, you get this one, tangent squared theta plus 1 equals secant squared theta. So if you remember this top one and you divide everything by cosine squared, you get this one, right? Because sine over cosine would become tangent, cosine squared over cosine squared would become 1. 1 over cosine reciprocal is secant, right? And then, so that's everything divided by cosine. Now, if you just memorize them, you don't really need to know that. But if you forget, that's a nice way to come up with it. And then this one is everything divided by sine squared theta. Same kind of reasoning here. We can, sine squared divided by sine squared is 1. Cosine squared over sine squared is cotangent. 1 over sine squared is cosecant squared. So if you memorize this one at least, and then this little trick to get the other two, you're good. If you don't remember it, if you just remember all 3, that's great. I have all 3 memorized. I think that's probably the faster way, but this is a nice way to remember how to do it. But yeah, this is kind of nice. If you have a 1, just a plain old 1, you can change it to a sine squared plus cosine squared. Or if you have a secant squared, you can change it into a tangent squared plus 1. Or if you have a cosecant squared, you can change it to a 1 plus cotangent. You can interchange these kind of really however you want. You can also rearrange these ones a little bit. So in the same way that sine squared plus cosine squared equals 1, you can also rearrange it to say sine squared theta equals 1 minus cosine squared theta. So what I did is I just subtracted this cosine squared theta to the other side, and now if I have a sine squared theta somewhere, I can change it to a 1 minus cosine squared theta, and that's kind of a really nice thing to be able to do. All right, so using all these rules together, we can kind of do something called simplifying, and we'll see some examples. So here's our fundamental identities here. This is kind of the thing that I'd suggest that you all, in a way, copy down. I will talk about this again in class. I'll encourage you to write it down again in class. Print it out if you can in some way. That would be a great idea. But just have it nearby as you start this. But one thing I really do want to emphasize, and I want to emphasize this a lot, is you do have to memorize. Okay, now we will be doing tests in class with this, and you will have to have them memorized. I will not give you a cheat sheet with these on them. So these ones you do have to memorize. Realistically, though, some of them you already know, right? You already know these reciprocal ones. You're pretty familiar with those. The quotient one, that's not too bad, right? Tangent, sine over cosine, cotangent, that's just flip, so you flip them. The Pythagorean ones, you do have to take some time to memorize those. Those are probably the hardest for most people to memorize, but they're very doable. And the negative angle ones, like I said, not used as often, but do take the time to know which ones the negative affect and which ones the negative doesn't affect. Okay? All right, let's try some problems here. So the first one here, it says, write tangent plus cotangent in terms of sine and cosine only, and then simplify. So knowing those identities, you should have written them down earlier on in the video. They should be somewhere on your paper, but knowing your identities is going to be really helpful for all these problems I'm going to demonstrate. We'll do some more practice in class, and hopefully it'll help a lot of you guys out. So what I'm going to do here is I'm going to start with tangent of theta plus cotangent of theta. All right, now I want to turn them into just sine and cosine. So if we look at our identities, the first identities that should come up that allow tangent to change to some amounts of sine or cosine is those quotient ones. So that would change tangent into sine of theta over cosine of theta. Plus cotangent is also a quotient identity. We can change that into cosine of theta over sine of theta. Awesome. All right, so we now have this sine over cosine plus cosine over sine, and the directions did say to simplify. So I'll keep going here. I'm going to make common denominators. So one has cosine and one has sine, so I'll multiply this one by cosine of theta on top and bottom. It's just like kind of like variables, just like solving for x type stuff or simplifying like any other parts of algebra. All right, so common denominators, I now have on the left side sine times sine, that's going to be sine squared of my theta, plus cosine times cosine, that's cosine squared of my theta, and all of that is divided by sine times theta times cosine of theta. Awesome. Okay, cool. Oh, hey, look, there's some more I can do. I know another one of my identities that we just learned is the Pythagorean, sine squared and cosine squared. That equals 1. So we can go ahead and change this into a 1 over sine of theta cosine of theta. All right. All right, now, so this is now kind of, depending on how you're going to read these directions, it's fairly following the directions. We turned it into sine and cosine, and we simplified. So I would say this is probably a fairly correct answer and valid answer, but if you don't want to leave your answer in terms of a fraction, if that's something you don't like or something you might not like, another, I think, equally valid answer would be to use your reciprocal identities. You have a sine in the denominator. You can move that up and change it to a cosecant of theta in the numerator. And then you have a cosine in the denominator. You can move that up to the top. So move the sine up. You can move the cosine up as well and change that into a secant of theta. So depending on how you interpret these directions and what simplify means when you're reading the directions, either of these I would say are valid answers here. All right, so we got a couple more of these kind of simplified type ones. We're going to kind of use a couple of the things we've talked about and see what happens. I'm just going to walk through them and kind of describe my work process. If you want to pause and try these two problems first, using the different identities to simplify. If we just want to watch and then we'll do some practice in class, I think that's a great idea. But once again, this is a confusing topic. You are going to need to practice. Thinking it's just going to magically make sense someday is not going to work well for you this time around. So when I see these ones right here, secant, cotangent, sine, one of the easiest things to do when you're simplifying these as much as possible, and here it specifies simplify means no fractions in your final answer, so no fractions in your final answer. So that last problem, we shouldn't have left the fraction. But the easiest and best way to start is to change stuff to all be the kind of same trig functions. And the easiest ones to go for is everything in terms of sine and cosine. So I see secant, I'm going to change that to be a 1 over cosine. I see cotangent, I'm going to change that to be a cosine over sine. And sine is already in terms of sine and cosine, so I'll leave that be. Well, let's look at what I have. I can kind of multiply this all together. I have cosine sine over cosine sine. Hey, well, if I have the same thing on top and bottom, then that's just 1. And so my final answer here for this one is just 1. So secant times cotangent times sine is just 1. All right, another one here, we have cotangent squared theta times 1 plus tangent squared theta. Now, there are a number of ways you can go about this. I kind of have 2 ideas that my brain wants me to do right off the bat, and you might get different answers either way. But one thing you could do, and this might be what your brain goes to, is when I see 1 plus tangent squared, I know that's one of my Pythagorean identities. So when I know that's one of my Pythagorean identities, I'm going to change this to be cotangent squared theta times secant squared theta. Now, I have those memorized, so it's really nice for me. I can just kind of reference them. If you don't have them memorized yet, you should work on memorizing them. Okay, I'll keep going. Cotangent, that can become cosine squared theta over sine squared theta using the quotient identity. And secant can reciprocate to become 1 over cosine squared theta. All right, hey, look, I have a cosine squared on top and bottom, so I'll cross those off. I'm left with 1 over sine squared theta, but my directions say no fractions as a final answer, so I got to reciprocate that one last time, change that sine, put it up in the denominator as a cosecant squared theta. All right, so let's do a couple more of these simplifiers. All right, so I have cosine plus sine in the numerator and then a sine in the denominator. All right, directions say no fractions as a final answer. So no fractions. So what I'm going to do is I'm going to divide both pieces. I'm going to distribute the sine, the division of the sine to both pieces. Make sure you do that to both pieces. So cosine theta over sine theta plus sine theta over sine theta. All right, sine over sine, that part became a 1. Cosine over sine, that becomes a cotangent theta. All right, no more fractions. I'm good to go. That's about as simplified as that one will get. It wasn't a squared, so can't really do anything else with it. All right, and then this last one that I'm going to do with you guys here in the video, I have sine squared theta over secant squared theta minus 1. Now, the secant squared theta minus 1 is a variant on one of our other ones. One of our identities, and I'll write this in a different color, was 1 plus tangent squared theta equals secant squared theta. That's one of our Pythagorean identities. Well, if I take this 1 and I subtract it to the other side, I get secant squared theta minus 1. Well, what does secant squared theta minus the 1 equal? It equals tangent squared. So I'll go ahead and change that to be sine squared theta over tangent squared theta. And I only know to do that because I know my identities. I've taken the time to memorize them like you should, and it'll help you out a lot in these problems to be able to do that. Okay, tangent squared theta, we can change that into sine over cosine. So we'll go sine squared theta equals sine squared theta over cosine squared theta. And then we're dividing by a fraction, so we'll multiply by reciprocal, so we get sine squared theta over 1 times cosine squared theta over sine squared theta. We'll cross off our sine squared theta, and we're left with just cosine squared theta. All right, now, a lot of your homework looks like this. These type of kind of simplified problems, we'll do a bunch in class. This is hard. This is new. You definitely need to take the time to memorize and practice a bunch. If you're struggling, come get help. We'll work through stuff. This is a lot of what the rest of the semester is like. This semester is significantly harder than last semester. So be ready to go. If you're not, come talk to me. All right, one last type of problem. This is a completely different type of problem. So we're going to go ahead and do this. It says, if tangent of theta equals -5 over 3 and theta is in quadrant 2, find the secant of theta. All right, well, here's the deal. What we're going to do is we're going to use one of our identities. Usually we probably use probably the Pythagorean identities, and we're going to plug these values in, and we're going to find what's missing. So one of our identities uses tangent and secant. That is tangent squared theta plus 1 equals secant squared theta. And so what we're going to do is we're going to substitute tangent to be -5 over 3. So we'll go -5 over 3 squared plus 1 equals secant squared theta. Okay, so what we're doing here is we're trying to solve for secant squared theta. This kind of makes sense, right? We substituted in what we knew. At the end, for most of these problems, we'll get a plus or minus, and that's where this quadrant 2 piece will come in handy, is helping us determine whether it's the plus or minus bit. Okay, so let's keep going. Negative 5 squared, that's 25, over 3 squared is 9, plus 1, make that 9 ninths, equals secant squared theta. All right, 25 plus 9, that's going to be 34 over 9 equals secant squared theta. We're trying to get secant by itself. So we're going to square root both sides. So we'll get the square root of 34 over the square root of 9 is 3, and that's a plus or minus equals secant of theta. All right, well, so now this quadrant 2 piece comes in handy. So quadrant 2 is this quadrant up here. If you remember, it was all students take calculus. So sine and cosecant are positive in quadrant 2. Everything else is negative. And since we're finding secant, we're going to keep it negative. So we'll say the secant of theta equals negative root 34 over 3. So this is another way of doing the type of problems we've done before. I want to see this be the way you do it this chapter. After this chapter, you can choose however you want to do a problem like this, but this is the work that I would need to have seen in order for you to get full credit. I need to see the identity. I need to see you plug it in. I need you to solve for what's missing. Okay? All right, with that, you should have enough information to be able to attempt the homework if you have time before class to get going on that. If you have any questions, please reach out. Otherwise, I'll see you in our next live session. And until then, I hope you have a great day.